That looks so bad.
All that gooey stuff right there.
Ooh. This is my friend Caleb, and Caleb recently thought he found himself a free 3D printer. But he didn't get it here, he got it here. And it wasn't until we got it back into the workshop that we realized why it was where he found it. The original hot end looks like a toxic waste zone, and it's easy to see why someone left this printer for the landfill. But we have a plan to save it. We're going to install a Manta M5P from BIGTREETECH and replace the entire brain of this printer. And then in a subsequent video, we're going to install a premium direct drive hot end from MicroSwiss. If you've ever taken apart an Ender 3, they're super easy to disassemble. These printers are so simple to work on. And for this particular rebuild, we decided to put that Manta M5P in this printer. Now, there's a couple of reasons we decided to do that. This main board has the ability to add a CB1 compute module to it. And what that does is it gives you the capability of running Klipper right on this board without having to have a separate Raspberry Pi connected to it. BIGTREETECH also sent us the TMC 2209 stepper drivers, and that means that this new printer with these stepper drivers is going to be near silent, which is a huge change from the original stepper drivers that came in an Ender 3 Pro. So as excited as we were to get this motherboard in, I made a bit of a rookie mistake, something that I didn't anticipate, because I've installed the SKR, what is it called exactly? This one. This is a bolt-in replacement, meaning you pull out the old board, you put this one in, you flash it with whatever firmware you're wanting to run, connect all the wires in, you're good to go. It's a drop-in replacement. That wasn't the case with the M5P, but I didn't realize that until we pulled the old board out. The M5P is a much larger board. It has a much larger footprint. So once we discovered that we weren't going to be able to just bolt this in, it was back to the computer so that we could design a new enclosure for these electronics. As we were designing this new enclosure, we realized that we hit another snag. This board is significantly taller than the previous board. So in addition to designing and printing a new enclosure for it, we also had to print standoffs so that we could elevate the printer's base higher off the surface to make sure that you had enough clearance, not just for the main board and for the enclosure, but also to allow for adequate cooling, because we didn't want the board or the compute module overheating on us. Now, I must say that when it came to installing this board, BIGTREETECH's wiki came in clutch. It helped us out a ton. It guided us step by step through the process. And whereas this board isn't super complicated to install, it does have a lot of pieces that you can configure. So you have to make sure you configure it correctly before you start using it. Since we were going to be using Klipper and the TMC 2209 stepper drivers, we knew that we could use those stepper drivers in what's called UART mode. And what UART mode does is it allows you to control the steps as well as the voltage, the VREF, which controls the current that the stepper driver uses, all in the software. Some stepper drivers, you actually have to configure jumpers on the main board to get the micro steps, and then you actually have to adjust the pot to get the VREF, which I know from experience is challenging, because the first time I installed an SKR Mini was because I had broken the pot off my last Creality board. Another cool thing you can do with this particular board is you can do sensorless homing, which means you don't need the end stops. Now, for us in this particular installation, we didn't go that route. We were trying to keep things fairly simple, and I didn't want to add just another layer of complexity. So that may be a future upgrade that we do, knowing that it's possible. The next thing we had to do with these stepper drivers is configure the voltage. Now, this isn't the VREF voltage, but this is actually the voltage going in. And the M5P allows you to have 12, 24, or 48 to 56 volts going into your stepper motors. So there's a jumper for the 12 to 24 volts, and then there's a jumper for, I think it's 48 to 56 volts. So you got to make sure that you set that voltage jumper accordingly to whatever your stepper drivers are and the power of your printer. And so for our case, we went ahead and set it to the 12 to 24 because the Ender 3 Pro has a 24 volt power supply. Next, we installed the CB1 compute module, and this was a little bit tricky to get installed. You do have to use a little bit of force, but you want to be careful because you don't want to bend those pins. Now, it's recommended that you install this with a heatsink. And so this is a bit of call out for you because if you didn't purchase the heatsink, it is sold separately. So if you buy this compute module, you want to make sure that at the time you buy it, you order that heatsink. That said, because we didn't have the heatsink and we were super interested in testing it, you may notice that the heatsink isn't installed throughout this video. We installed it at a later date, but we also made sure that we configured Klipper so that it would shut the printer down if the compute module got too hot. That allowed us to at least do some test prints. The final jumpers that we configured on the board are for the fans. Now the 40mm fans that are on the case of the Ender 3, as well as the same fan that's on the hot end, these fans are found in multiple varieties. I think you can get them in 5 volts, 12 volts, or 24 volts. The particular fans that come on the Ender 3 are 24 volt fans. So we had to make sure that on the M5P, we set the jumpers for the voltages for the fans so that they were getting 24 volts. Now below, I'm going to include a link to the wiki so that you can look through the documentation in case anything arises or you have any questions. One other thing I wanted to mention about this board, because we didn't do this on our printer, but when I realized it was possible, it got me really interested in trying this. It has 2 JST connectors on the board for RGB lights. And what this means is you could actually run an RGB strip on your printer from this main board, and you could actually have it give you warning notifications or even have it be a progress bar that tells you, visually how close you are to finishing your print. I think that would be something super cool to do and fun to mess around with. Now, when it came to wiring up this board in the custom enclosure that we had built on an Ender 3 Pro, we really only ran into one snag, and that was with the Z-axis wiring for the Z stepper motor. The wires were just about 10 mil too short, and so we had to go ahead and cut that connector off, and we soldered on another connector, extended the wires. One thing that was kind of interesting that I ran into, again, that I wasn't expecting, and it was in the documentation, but as I read it, I don't know if you read like I do, but I don't really pay attention to the details. The CB1 has a specific Linux image that is different than the Raspberry Pi image because it uses different chips on that board. Make sure you use the correct version of the image, because on our initial boot up, I had just a default Raspberry Pi image installed on our SD card and the system wouldn't boot. But all in all, is a quick fix. It was in the documentation. It was just on me for not reading it clearly. So yes, we're going to install a direct drive extruder from Micro Swiss, but really at this point in the build, we wanted to kind of test and see how everything was going. How is it going with just the main board, and kind of maybe get a baseline print to compare that with the new nozzle to the old nozzle. The challenge was this nozzle had gotten so hot that everything was completely fused. This went from a part that needed to be replaced to a completely fused block of junk that just had to be thrown away. So now that we installed the Manta M5P and everything was running perfectly, we still had a couple of unknowns. One being we did not have a Z-axis end stop because we were planning on installing a BL Touch. And that BL Touch, well, it'll be installed when we install the Micro Swiss hot end assembly. So we were kind of at a stopping point where there was nothing left for us to test, and we just needed to install that new hot end. So next video, Caleb and I will be installing that hot end. Until next time,